simple as you think, Telephony. Eggnog doesn't grow on trees.
The performance of early telephone transmitters could vary greatly with the angle at which they were held. The pedestal or pillar telephone, more familiarly called the candlestick, attempted to overcome this problem by trying to oblige users to keep the set in an upright position where the transmitter was at its best. The transmitter fitted to this GPO telephone number 150 was made by Western Electric 100 years ago. Transmitter number 1 is a fixed solid back design. Speaking into it causes the diaphragm to vibrate, varying the electrical resistance between two metal plates by compressing about half a gram of crushed anthracite granules, sieved to be of uniform size, and sandwiched between the diaphragm and the back of the transmitter. Through the 1920s, transmitter number 1 could be found in telephones across the world, but 1929 saw the introduction of transmitter number 10. This was an inset type, that is a plug-in unit that could be easily replaced in the field. Unlike the number 1, the two electrodes in the number 10 transmitter were entirely immersed in carbon granules, making the number 10 less sensitive to positioning and therefore suitable for use in handsets. In 1930, a post office committee determined that the cost of maintaining number 1 transmitters in the field was excessive and that wherever necessary they should be replaced by the newer type. The result was the Bakelite housing, known as transmitter number 22, seen today on most surviving Type 150s. This has a contact spring and pin identical to those found in the 164 handset, and contains the same inset transmitter. The column or pedestal format also allowed a larger and therefore more effective receiver magnet. Handsets had been made with large soft iron magnets, but it was the use of an alloy of aluminium, nickel and iron that made the compact 1L receiver and thus the 164 handset possible. When telephone number 150 was designed, public switch telephone networks aimed to transmit commercial speech, i.e. sound at frequencies between 500 and 2500 Hz. Sounding rather like this.
This is how a telephone conversation sounds with a solid back transmitter working to another 150. Is the quality better than you would have expected?
Despite its complexity, size and weight, the 150 was not a complete telephone. The induction coil, capacitor, and of course the ringer had to be fixed to a suitable wall in a separate timber housing designated bell set number 1. This example is dated 1926 and is sadly missing the metal cover protecting the clapper. The subtle blued finish has also been stripped from the gums to reveal the ugly bare brass, an act of vandalism that would have appalled its makers. By the 1920s, considerable progress was being made in cities with placing telephone cables underground. Elsewhere, however, overhead wires were the norm. Premises served by overhead wires therefore needed fuses and lightning protectors like this to reduce the risk of damage or fire from a lightning strike or contact with a high-voltage cable. This 1932 box is made of vulcanite, heat-treated rubber. A Bakelite version was to follow. Each contained 2 fuses and 2 molded carbon spark gap type protectors. After the First World War, the GPO were able to resume the work that they had started in 1912 to improve the telephone network. The majority of exchanges were still manual, but the 150 had provision for a dial. This number 10 dial has an early solid copper finger plate. Now we're looking at the detail of the 150. Should you find yourself doing the same, something often missed is that the weighted base has to be replaced in a specific orientation to maintain the stability of the set. This is achieved when a small tag on the shell engages loosely with a notch cast into the base. Well, this has turned out to be quite the magnum opus, and to be honest I feel like I've rabbited on long enough, so let's close by taking a look at some circuit diagrams and seeing the dial and the ringer in action.